In this lesson, we're going to continue working with radicals and extend what we talked about in the last video, which was simplification and addition and subtraction. So today we're going to be looking at multiplication and division. When you multiply radicals together, you're going to simplify each radical by taking out the buddies. So you're building your prime factor tree and simplifying that expression. After you get the simplified expressions, then you're going to multiply the coefficients together and the radicals together. So when we added and subtracted, we said we had to have like terms. We had to have the same number under the radical. We don't have to do that with multiplication. We can multiply the two numbers under the radical together to get a new radical. One thing you want to be aware of is sometimes you have to simplify again because you may have gotten a number that was no longer in simplest form. So always check that to make sure that you simplify again if needed. So for this first example, we have 5 times the square root of 12 and 3 times the square root of 15. Now students will ask, well, can I go ahead and just do the multiplication first and then simplify? And you can, but you're going to have a larger number that you're going to have to simplify. So I prefer to simplify before multiplying. So again, we look for factors of 12, so 3 and 4 will work. You could have also used 2 and 6. And then 2 and 2 are the factors of 4. So then we look for the pairs, so we have a pair of 2's. Remember, when the 2's come out in the front, they're going to multiply by the 5 to give us a 10. And then I still have a 3 underneath because that one didn't have a partner. And then we're also going to simplify 15. But when I do that, I know that 15 is 2 prime numbers, so I actually can't simplify that one anymore, so that would just be 3 radical 15. So the next step is to multiply the numbers on the outside. 10 times 3 is 30. Under the radical, 3 and 15 would be 45. So at this point, 45, we need to look at its factor tree. So we would have a 3 and a 15, and we already know that 15 can be divided into 3 and 5. So see, that's where we have our pair of 3. So that's why we said we want to make sure we go back and check. So the 3 is going to come to the outside and be multiplied by the 30. So 30 times 3 is 90, and then under the square root we have 5 left over. So the simplified answer would be 90 times the square root of 5. In number 2, 2 and 5 are both prime numbers, so we don't have to simplify. We're actually squaring the same thing with a radical twice, so they could have written it like that. So we're going to multiply 2 and 2, so that's 4. 5 times 5 is 25. 25 is one of those perfect squares, so I can go ahead and take the square root of 25, and then we're going to multiply 4 and 5 together. So my final answer doesn't even have a radical in it. We were able to get rid of the radical when we multiplied those together. And then for number 3, let's go ahead and factor 8. 8 will factor into 2 and 4. 4 will simplify to 2 and 2, so there's our pair. So again, when those come out in front, we have to multiply them by the 3. 2 times 3 is 6. And we have a 2 left under the radical. 24. We can do 4 and 6. 4 is going to factor into 2 and 2. And then 2 and 3. So a pair of 2's out in the front to get multiplied by the 2. So that's 4. And then under the radical, we have a 2 times 3, which is 6. And now that we've simplified, we want to go ahead and multiply. 6 times 4 is 24. 6 times 2 is 12, and we know that we're going to have to simplify the 12. Sorry, I keep writing that in parentheses, and I really don't need to. Actually, we've already done 12. It's right up here on the top, so we can take that where we've previously done that. So we know we have a pair of 2's that come to the outside, so 2 times 24 is 48, and then we would have a radical 3. That didn't get to leave the inside. So simplifying square roots and fractions, which is division or rationalizing the denominator. Again, we want to reduce first if possible. So if I have two things under the square root, I might need to think about simplifying the fraction first. The other thing we can do is split up our fraction. So we can think about the square root of a over b as the square root of a divided by the square root of b. And so if I had numbers, we would think about this as the square root of 2 over square root of 25. And again, 25 is a perfect square, so we could even go ahead and write that as radical 2 over 5. We're going to simplify the numerator and the denominator separate of each other, so we still have to go back to our factor tree. And then the last step is to reduce the result if possible. So you're checking the coefficients to see if that fraction is going to simplify anymore before finalizing your answer. If one square root is left in the denominator, we don't want that. We don't want the radical in the denominator. So we're going to multiply the top and the bottom of the fraction by the square root. And again, we always go back to simplification before we say we have a final answer. So let's kind of see some of those different things in practice. So square root of 7 over the square root of 3, that fraction doesn't simplify, so 7 over 3, so I go ahead and split it apart into two radicals. They're prime numbers, so that I know that they're not going to simplify anymore, but I don't want a radical 3 in the denominator. So to rationalize the denominator, we use multiplication, and whatever radical is in the denominator, I multiply by that over itself. And then when we multiply radicals together, again, they don't have to be the same number. I just would multiply 7 times 3 is 21. And then the denominator is the square root of 9. 3 times 3 is 9. And then we know that that's a perfect square, and that would be 3. So our final answer for this one would be a square root of 21 over 3. I don't have anything else that's going to simplify out of 21. In number 2, again, we can start by splitting the radical. So I have the square root of 40 over the square root of 3. And I know that 40 is going to simplify because that's definitely not a prime number. So let's go over here to our factor tree. So 2 and 20. We have 4 and 5. And then 2 and 2. So for that numerator, the pair of 2's would come out in the front. I have a 2 and a 5 left, so that would be 10 over radical 3. So at this point, we would look to see if we can simplify anything, which we can't, but we have that radical in the denominator. So again, whatever radical is in the denominator, that's what we multiply by, and whatever we do to the top, we have to do to the bottom. So we would have 2 times the square root of 30, because the 10 and the 3 would be multiplied together, over 3. And again, the radical 3 times radical 3 is the square root of 9, which is just 3. So now that I have this 30, I got to think about, okay, can I simplify the 30 anymore? So let's go ahead and build our factor tree for 30. Well, I have a 2 and a 3 and a 5. I don't have any pairs of numbers, and the fraction 2/3 won't simplify anymore, so our final answer would be 2 radical 30 over 3. For number 3, we're going to think about this in two separate parts. So we would have the square root of 75 over the square root of 15. And I'm just going to work down here, and then I'll erase this in just a second. So 75 would be 3 and 25. And again, 25 is a perfect square, so 5 and 5. So the 5's leave the radical, the 3's stay in, and then 15 is 2 prime numbers. So we've already factored that one several times. So that one's going to stay as the square root of 15. And again, I don't want that radical. I can't simplify the 5 and the 15 because the 15 is trapped under that radical. So I can't do anything until I multiply by that square root. So 5 and then 3 times 15 is 45 over 15. But again, I've got that 45. I'm going to have to simplify that 45. So let's build out the factor tree. 9 and 5. 9 is a perfect square, which means some 3's get to leave. They get multiplied by the 5 that's already there. So 5 times 3 is 15. I would have a 5 left. Well, look at that. I had a 15 in the denominator. 15 divided by 15 is 1. So my final answer for this one is just the square root of 5. So again, there's lots of like checking and going back to make sure that we're catching everything and simplifying where we can. 36 is a perfect square. Square root of 36 is 6, so we don't need to build a tree for that. And 8, we would have 2 and a 4, and a 2 and a 2. So the pair of 2's are going to leave the house. The other one stays underneath. So for this one, we're going to look at this 6 divided by 2. It's almost like it's a fraction. So 6 divided by 2 is 3. It doesn't just go away. We have to keep that as part of our answer. And we'll get rid of our factor tree. And so we still have that square root of 2 in the denominator, but that's mathematically a no-no. So because that's the radical in the denominator, that's what we multiply by. So the numerator would be 3 radical 2. I can't multiply the 3 and the 2 because the 3 is not under a radical. And then radical 2 times radical 2 is the square root of 4. And the square root of 4 is 2. And then we would just double check. If that 3 over 2 could have simplified, I would, but it won't. So that's my final answer. All right, number 5. We have a 52. So I'm going to come over here and do my factor tree. So 52, 2 will go into 52, how many times? 26. I knew that, but I wanted to double check. And then 26 has factors of 2 and 13, which are both prime. So we have a pair of 2's, and then we have the radical 13 because it doesn't have a partner. And then in the denominator, the square root of 4 is 2. So we're multiplying 3 times 2, which is 6. And again, we want to look at this fraction. So 2 over 6 is the same as 1 over 3. So we would still have the radical 13 in the numerator, but the denominator simplifies to be 3. So all those things that you learned about fractions, we're using with our radical expressions. All right, number 6, the last one, the square root of 4. That's a perfect square. It's 2. 2 times 2 is 4. 6 radical 3 can't be simplified, but I don't want the radical. So again, whatever radical is in the denominator, multiply by itself over itself. So 4 radical 3, because I can't multiply the constant by the radical. And then in the denominator, the square root of 3 times the square root of 3 is square root of 9, which is 3. 3 get multiplied by the 6, which is 18. So 4 radical 3 over 18. We obviously have a fraction to simplify because both of those things are divisible by 2. So factor out the 2, and our final answer would be 2 radical 3 over 9. So lots of simplification, lots of canceling to make sure that we get to the final answer, lots of perfect squares, things like that. When we have a denominator that is 2 terms, so I have a radical, but it's being added or subtracted to something else, we use something called the conjugate, which is the same binomial, so two terms, but we're either changing the plus to a minus or the minus to the plus, and then we're going to multiply together. And when we do that, we kind of cancel some things out. So in number 1, again, the conjugate is the exact same expression, but with a different sign in the middle. So if that's a plus in the original, its conjugate is going to have the subtraction. And if I multiply by anything divided by itself, I'm multiplying by 1. I'm not changing the value of the original expression. I'm just using this as a way to get it into a more mathematically appropriate form so that we don't have the radical in the denominator. So we have to think distributive property, which means that if this is in parentheses, the 3 has to be distributed to both of those terms. So 3 times 2 is 6. And then we would have 3 radical 7 because I can't multiply those together. In the denominator, we have to be careful because we actually have 4 things that we have to multiply together. So we have to multiply the 2 times the 2. We have to multiply the 2 times the negative radical 7. So that would be negative 2 radical 7. I have to multiply that positive radical 7 by both of those terms. And when I multiply radical 7 times radical 7, that's the square root of 49, which is just 7. So these two terms cancel each other out because addition and subtraction, I can subtract them or add them because they have the same radical. One's positive and one's negative. So that's the whole point of the conjugate, is now you see that we've gotten rid of that radical in the denominator. So the numerator, 6 minus 3 radical 7. My denominator is 4 minus 7, so a negative 3. We still want to think about fractions, but we have 2 fractions we have to think about. We have to think about this combination and this combination. So I need a number that divides into all 3 of those things. So 3's and 6's are all divisible by 3. So 6 divided by negative 3 is negative 2. Negative 3 divided by negative 3 is a positive 1. Radical 7. So that can be a little tricky until you get used to thinking about both of those combinations needing to be factored out. And then for number 2, I have 2 radicals, but again, it's the denominator that we're trying to work with. So we're multiplying by the conjugate of the denominator. Top and bottom. Okay, and distributive property, we got to multiply all 4 things together. Now if you struggle with some of that, don't forget about your box. Like we could still take and set up boxes and multiply. So 2 times 3 is 6. We would have 2 radical 6, 3 radical 5, and that last one would be square root of 30. So we would have 3 plus square root of 6. We can just take the numbers right off the sides of the boxes there. And then in the denominator, we would have a 3 and then a negative radical 6 and a 3 and a positive radical 6. So 3 times 3 is 9. We have 3 radical 6. This would be negative 6 because it's a negative and a positive, and then the square root of 36 is 6. And this one would be negative 3 square roots of 6. So again, these cancel out because I have a positive 3 radical 6 and a negative 3 radical 6. Remember, that's the whole goal of that conjugate. So in the denominator, I would have a 9 minus 6, which we know is going to simplify to be 3. So now I've got to add. So I have, oh, I wrote the wrong thing. Something's not right here. This one I copied, that should be a, oh, I copied that whole thing wrong. Let's fix that real quick. I should be having things inside of the boxes, not the things on the sides of the boxes. So 3 radical 5, 2 radical 6, and 30. Okay, so sorry about that. So I can't add these until I know that I have the same number of the radicals. So let's look at that 30 really quickly, because the 6 and the 5 aren't going to simplify anymore. And actually, the 30 won't either. So there's nothing in that numerator that we can simplify. The only thing that we can change is we can simplify that to be a 3. And that would be your final answer, because based on what we know about addition and subtraction rules, I cannot add or subtract any of those in the numerator.